Miss you guys. This is how we'll be doing lessons for the time being. So let's have some fun. It's a lot of pausing and doing work, so make sure you're keeping up with that. And when you have questions, please just ask me. Thanks. For today's lesson, we're going to take some data. So if you have a handful of coins, I have all pennies because I went to school and grabbed some. But if you don't, you can use other coins. If you don't have coins, that's okay, but it's kind of fun to get your own data. And you're going to see how many you can stack on top of each other with your non-dominant hand. So for me, that's my left hand. Now here's the rules, is once you place a penny, you can't touch it. And you have to just do one at a time. And once your tower falls over, you're going to count and see how many pennies you got to stack before it fell over. Now you can do this 1, 2, 3, 4, 5 times. It really doesn't make a huge difference, but the more data we have, the better. So we're going to use that data in our dot plots and histograms coming up. All right, let's get going. So the first thing I want you to do is to look at this graph, analyze this graph, and what we have is our commute time. That means how long it takes someone to get to work. And then our count here is how many people fall into that range. So if you look at this column, most people are between about 20 and 26 minutes. There's a lot of people in that column. So there's about 210 people in that column. So what I want you to do is pause the video, and I want you to write down 3 observations about this data. All right, so moving on to the meat of the lesson is, so far we've studied linear functions, which made a line, exponential functions, which made the curve. We've used these functions to represent relationships between 2 variables, x and y, for many different scenarios. What if we wanted to study just one variable, though? Instead of 2 weeks and money in the bank, we just wanted one variable. What types of graph could we use to do this? So in this essential outcome, we will learn how to collect, represent, and analyze data using a variety of statistical methods. So we just did this penny experiment. I had you do that at the beginning, where you stacked, and again, normally it would be a whole class thing where everyone's doing it, we're getting class data. Unfortunately, we are confined just to this. So what we have here is the class data from one of my classes last semester, and this is how many pennies each of them stacked. So we had about 20-some students, and you can add your data in wherever it works. So what we're going to create first is a dot plot. Now what a dot plot is we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you're going to make that number line all the way to your biggest number, and you're going to put, for example, this 3 is going to go over, there's going to be 1 dot above a 3. If there's multiple, like above 50, you would put 1, 2, 3 dots over it. So each dot represents one person that stacked that many pennies. So pause the video, take some time, and create that dot plot. Once you're ready, once you have your dot plot created, unpause it. So your dot plot at the end should look something like this, similar to this, with your data added in. So, moving on. A different class stacked pennies with their dominant hand and decided to represent using a frequency histogram. So we used a dot plot, but they used a frequency histogram shown at right. How is a frequency histogram different than a dot plot? Try to answer that yourself. What do you notice about this frequency histogram? What's similar and what's different between frequency and the dot plot? How does that graph relate to this dot plot? Well, a frequency histogram represents how many fit into a certain category. So if you look at this right here, this is 1 tall, and 1 person was between 4 and 8 pennies stacked. So that's what that means in this context. Here we have, look over to that, we have 6 people who stack between 48 and 52. So what does the word frequency mean? Frequency means count. How many? Frequency, and if you look back at our intro graph, it's the same thing as count. It means how many people fit in that category. So what is the scale on the x-axis? Fill in the missing labels. So what we have here is we're saying, okay, what are we counting by? If we go every 2, that means we're counting by 4. So we're going to fill in all these missing labels on that graph. That's what that means. And then how many students do you think were in the class? So how could we count how many students were in this class? I want you to pause the video and try to see if you can count exactly how many students were in this class. And try to get a strategy for that. So how I would have done it, and this you can see if this matches your strategy, gets the same answer or gets a different one, is here we have 1 student. Here we have 2. 1 student, 1 student. Here we have 4. Here we have 2, 3, 1, 6, and 2. We're going to add all those numbers together. 2 plus 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 students in this class. So we're going to create a histogram, frequency histogram for our data. So the first thing you need to do is draw our axis. You need to pause the video to do that. Be my guest. And next we're going to label our x-axis. So we're going to actually use the same labels as they used above. So we're going to have 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56. So that's all of our x-axis. And then on our y-axis, we want to do our count. Or you could say number of people or frequency, whatever you'd like. I'll just write count for now. And that's 0, and we're going to count by 2s. 2, 4, 6, 8, and 10. So we want to see how many people fit into each column. So we go back here, and we see that there is 1 person in that 0 to 4 range. So on our frequency histogram, in that 0 to 4 column, we're going to fill it in 1 tall, representing 1 person in that range. Next we go, how many between 4 and 8? Well, that's none. How many between 8 and 12? Well, we have this 11. 11 is between that 8 and 12. So we're going to go back to this column, and we're going to fill between 8 and 12. There is 1 person. Now your data could be different than mine because you stacked it yourself and added your numbers in. It doesn't have to match exactly, but you're going to look at this data here and you're going to fill that all in. So we're going to do one more together because we need to learn one important thing we need to remember here. If we look between 12 and 16, there's none, and then 16 and 20, there's 2 numbers that would fit that. But this 20 number is on a border. So that's going to go with the 20 to 24 group. If it's on a border, it goes up. So what that looks like on our graph is we have just 119. And so in that 16 to 20 range, the 19 person is right there. But that 20 person is going to go in that next column. So if we look at 20, between 20 and 24, there's 1, 2, 3 people. So we're going to go to our histogram. We're going to fill that. 20 to 24 has 3. So I'm just going to leave it on the data. And I would like you to, again, pause the video and complete our histogram using all that data, including your numbers as well. Don't forget your data you counted if you did that, and you're going to complete that histogram. So you should have some sort of boxy looking chart representing that. So here's what my histogram will look like. Yours should look pretty similar if you added your own data. And we are going to start describing some shapes. So there are 3 different shapes of distribution: symmetric, skewed right, and skewed left. So each shape is represented in both a histogram and a dot plot. So we're going to label each of these. Now, if you can see up there, it's someone skiing. We're going to use that for our description of the shape. So first, let's just start with the easy one, the one we all know. Symmetric means it's pretty much, you can fold it over. It's like a midline where it's the same on both sides. That's shape number 2. That's symmetric. What we do is we draw like a curve over our data. And you can see it's symmetric. It just has one hump where everything meets in the middle. But these other 2, here, most is concentrated on the right. Here, most is on the left. We're going to draw a curve over that. And I've got a question for some of you, which is, if you were going to go skiing, like Mr. Blythe here, which way would you ski on this mountain? Now, some of you are crazy and you might go to the right, but personally, I'm going to skew to the left. If I'm up here on top of this mountain, Mr. Blythe, get his arms, little poles in there, goggles, with a nice big helmet. I'm going to ski you to the left. So we call this skewed left. You would skew left. Now over here, if we draw a curve, it goes up, and then it goes, flattens out. If you were me, I would sure much rather skew down that shallow side. You could be crazy and go down the, bomb it down the steep part. That's not me. So we call this skewed right. So those are our 3 big words for shapes of distributions. If you ever forget, just think of skewing. Which way would you skew? Here, we're skewing to the left. Over here, we're skewing to the right. All right. And to close out today's class, what I'm going to have you do for closure is you're going to create a dot plot and a histogram Venn diagram. And you're going to take a picture of this Venn diagram you create. You're going to upload it to Google Classroom. So all I need you to do is say what only pertains to dot plots, what only pertains to histograms, and then what similarities do they share. I want you to try to get at least 6 things and make sure there's at least 1 in each. And then you're done for your first lesson. Thanks for joining us on Mr. Blythe's YouTube Classroom.